To find all the zeros, we start by looking at the degree, and we see the degree is 3. That means I'm going to have 3 zeros of this function. So in order to get started, in order to find that first one, I need to make a list of all the possible rational zeros. And that's going to be all of the factors of the constant term 2 over factors of the leading coefficient 1. So the only factors of 2 are 1 and 2. The only factor of 1 is 1. So my possible rational zeros are plus or minus 1 or plus or minus 2. So there's only 4 possible rational zeros. So we start using synthetic division to check those. And to maybe narrow our focus, if you have a graphing calculator, you can graph this function and look at the graph and see where it appears to be crossing the x-axis. If it appears to be crossing at either -1, 1, -2, or 2, go ahead and start by plugging that particular number in. But without looking at a graph, we can just start punching these values in and checking them with synthetic division. So I'll put a 1 in the box and set up my coefficients. Now if I get a remainder of 0, then that means that this number is one of the solutions. It's one of the zeros of the function. If I don't, then I go ahead and move on to the next one. Okay, and so here, using a 1 there did not give us a remainder of 0, so just go ahead and move on. Let's go ahead and try a -1. And that is not going to give us a 0 either. And so go ahead and try a 2. And there we have a 0. So 2 is one of our solutions, one of our zeros of the function. So let's go ahead and keep track of that. Now at the very beginning I said there's going to be 3 of them because the degree is 3. So obviously the other 2 are not going to be found in this list because we only have one more number in this list. It is possible that 2 is a 0 again of multiplicity greater than 1, but most likely the other 2 zeros are not going to be found in this list. And so at this point, since we started off with a x cubed, a degree 3 polynomial, when we did our synthetic division, then this quotient down here is going to be a degree 2 or an x squared polynomial. And so let's go ahead and set that up. That would be 1x squared plus 3x plus 1. So my other 2 solutions here are going to come from setting that equal to 0. So once we get down to where we have a quadratic or an x squared polynomial, we don't need to check the numbers in our list of possible rational zeros anymore. We can set up our quadratic equation and solve it either by factoring or using the quadratic formula. This one cannot be factored, so we go ahead and do the quadratic formula. X equals -b, so -3, plus or minus the square root of b squared, so that's 9, minus 4 times a times c over 2a. So let's go ahead and see if we can simplify that. So it's just going to be 9 minus 4 in there, so that's 5. And so there's our other 2 zeros. So our zeros are 2, -3 plus square root of 5 over 2, and -3 minus square root of 5 over 2. So that accounts for all 3 of the zeros that we were expecting because it was a degree 3 polynomial.